Good morning, Honors Biology. Today is Thursday, September 10th. Today we're going to be working with atomic number and atomic mass. This is the worksheet you're going to need to complete. But before we get there, I'm going to go ahead and open a blank doc in Kami, and this will allow me to show you how you can get the information to solve for today's problems. One thing you might want to have open is a website called ptable.com that gives you the periodic table right at your fingertips, or you can use the uh, inside back cover of your textbook that also has the periodic table. All right, so we're going to use this to highlight how you can find all of the different subatomic particles in a particular element. And the first thing you might notice is that you have a hydrogen here and a hydrogen here. So that is going to be based on the fact that you can have different isotopes of certain elements. So keep that in mind. Going back to your definition from the notes, again, an isotope is going to be an element that has different number of neutrons. So do not email me telling me there's all these different forms. I understand that those are called isotopes. So let's get into how you can find this information that you need. So I went ahead and highlighted here. This is, again, there's a lot of useful information in the boxes on the periodic table for each element. So we're going to look at vanadium. So that's 23V. So let's go ahead and get that out here. So again, you had 23V. And then what else did you have? 50.942. So you had 50.942. So each element is going to have its own box on a periodic table, and this is basically the most common information you're going to have. Well, this first thing is going to be the atomic number. Then you're going to have your symbol. Then you have the name of the element. And then you're going to have the atomic mass. And the atomic mass, these are averages. So for vanadium, you have 50.942. The first thing you want to keep in mind is when we're doing these problems is we're going to want to make these whole numbers. So really for this, we would refer to the atomic mass as being 51 for its atomic mass. And really what that means is that if you had a mole of vanadium, so that would be 6.022 times 10 to the 23. If you had those number of atoms and you put them on a scale, they would weigh, or their mass would be 51 grams. That's what the atomic mass means. All right, so we can get all the information from as far as the subatomic particles. So we can get the number of protons, the number of electrons, the number of neutrons, and that atomic mass just from this. So your atomic number is going to equal your number of protons. So for this case, you would have 23 protons. And let's look at the chart. I don't think it's asking you. No, it doesn't mention anything. But you automatically know you're going to have then the same amount of electrons. Remember, your protons are positive, electrons are negative, and then your neutrons are neutral. Okay, you also have an atomic mass of 51. So what you want to do then, in order to determine the number of neutrons, you have to take the difference of from 51 of 23. So that would be 48. That would be 28 neutrons. So if you add this and that, that's going to give you the atomic mass. And if you think about that from the notes, the protons and the neutrons are found in the nucleus. And they're held together, and that's where you get the majority of the mass of an atom. The electron mass is so small that we basically neglect it when we calculate the atomic mass. So that atomic mass is going to come from the number of protons and the number of neutrons. All right, let's do one more example quickly, and let's do a big nasty one. So we're going to do 80 mercury, and then we'll find all of the subatomic particles. So we're going to do 80. What is going on here? I don't know what that is. Let's get rid of that. Sorry. So we have 80. And mercury does not. It has the symbol Hg. So that has nothing to do with how we say the English word. That comes from its Latin roots. So Hg, and then let's look at what its atomic mass was, 200.59. So 200.59. So protons, electrons, neutrons, and its atomic mass. So 200.59, since we have the 5, we can go ahead and make that 201. Number of protons is going to equal your atomic number, so that's 80. And again, even though we're not doing it, just please make sure you know that the protons and electrons are always equal. So then the number of neutrons, we're going to subtract 80 from 2001. So that should be 121. And then you can add those together to get the atomic mass. All right, so let's go back here. And I have a little shorthand for you that'll help you solve these problems. So again, remember the atomic number is going to equal the number of protons. Right? So if you have a number here, it would be the same here. So the number of neutrons would be taking that atomic mass, and we sometimes call it the AMU, atomic mass unit, and you would subtract the atomic number, again, which is the number of protons. And then to get the mass number, you would take the atomic number, and then you would add the number of neutrons. So again, just little formulas that'll help you fill out this sheet. And please be aware that there are a few questions at the bottom that you need to make sure you answer. Any questions as they come up, feel free to email me. Other than that, complete this and have a good day. Bye.